Geometry Lesson 3.2, Proving Parallel Lines. In the last section, we discussed the relationships of angles formed by transversals. In this section, the converses of the postulates and theorems we learned in 3.1 will be used to show that lines are parallel. So in the last section, we learned the alternate exterior angle theorem. If two parallel lines are cut by a transversal, then the alternate exterior angles are congruent. So we learned that angle 1 was congruent to angle 8, and angle 5 was congruent to angle 4. So they're outside the lines and they're opposite each other or alternate of each other. In lesson 3.1 we had the corresponding angle postulate, and that one once again was stating that two parallel lines are cut by a transversal. Consequently, then we'll have corresponding angles. But in lesson 3.2, the converse of that postulate gives us the information that we have the corresponding angles. Consequently, the lines are parallel. So if angle 5 is congruent to angle 7, then line A and line B are parallel lines. Angle 5 and angle 7 are corresponding angles. So let's take a look at example 1. It says, find the value of x that makes lines A and B parallel. Go to page 114 in your book, and I want you to make a drawing of that figure. Be sure to label your lines and then put in the values for the angles. Now if we take a look at these angles, this is the transversal T across the two parallel lines A and B. It's just like we've had before, except they just turned the drawing a little bit. These two angles are corresponding angles. Because we know that corresponding angles are congruent, we can set the values equal to each other, and then we can solve. So 6x minus 8 equals 4x plus 12. We'll go ahead and subtract 4x from both sides, and then we'll add 8 to both sides to solve this. And 6 minus 4 is 2x. And 7 plus 8 is 25. So x would be 25 divided by 2, or we could also say that that's 12.5. Then you'd go ahead and substitute your 12.5 into the angle, and for the first one, 6 times 12.5 minus 8 equals 67, and 4 times 12.5 plus 17 will equal 67. So you solve that correctly. The converse of the alternate exterior angle theorem, theorem 3.2.1. If two lines are cut by a transversal, this would be line A and B cut by transversal T, so that alternate exterior angles are congruent, then the lines are parallel. So if angle 4 is congruent to angle 5, then A is parallel to B. The converse of the alternate interior angle theorem, there's our interior angles. If angle 2 is congruent to angle 7, then line A is parallel to line B. That was theorem 3.2.2. Be sure that you have these on your paper with the theorem number, and which angles they involve. The converse of the consecutive interior angle theorem, this is theorem 3.2.3. If two lines are cut by a transversal so consecutive interior angles are supplementary, then the lines are parallel. Angle 6 and angle 7 are supplementary. Consequently, line A is parallel to line B. Next theorem, theorem 3.2.4, the converse of the perpendicular transversal theorem. If two lines are perpendicular to the same transversal, then the lines are parallel. So they're talking, when they say two lines, about line A and line B to transversal T. Remember, we had the theorem that said if one of these angles is 90 degrees, then the other one has to be 90 degrees. So if A is perpendicular to T and B is perpendicular to T, then A is parallel to B. Let's take a look at example 2. Example 2 on page 116. Prove the converse of the perpendicular transversal theorem. We are given that A is perpendicular to T and B is perpendicular to T. And let me rewrite T in there. There we go. Prove that A is parallel to B. So we have our given, and we move our given down to statement 1. And we have our reason. And we have our prove, and we move that down to the last statement. And let's begin. So what does this show us when we have these perpendicular lines? Well, it shows us that angle 1 and angle 3 are right angles. And that would be a definition. That's the definition of perpendicular lines. So now we know that they're right angles. What do we know about right angles? Well, right angles are congruent. This right angle, angle 1, is 90 degrees. This right angle, angle 3, is 90 degrees. So let's state the congruency. And angle 1 is congruent to angle 3. And that is because all right angles are congruent. We can now state, because these are both congruent, that angle A is parallel to angle B, and that's because of the postulate we just learned. So that's the converse, and I'm going to shorten this, of corresponding angle postulate. Usually when you have right angles, you will prove either 90 degrees or you will prove congruency right after. The transitive property of parallel lines, theorem 3.2.5. Sometimes in a drawing you'll have more than one parallel line. You need to understand that those lines will all be parallel to each other. So if two lines are parallel to the same line, then they are parallel to each other. We call this the transitive property because if A is equal to B and B is equal to C, then A is equal to C. Do you remember that? In this case, if A is parallel to B and B is parallel to C, then A is parallel to C. And I've shown this by making two red arrows for A and B and two green arrows for B and C. Let's look at example 3, which is also on page 116. Now we have a new situation. We have two parallel lines being crossed by two transversals. Even though there's an extra transversal, this does not change the properties of the angles. It says which lines can be proved to be parallel from each given statement. State the postulate or theorem that justifies your answer. So, angle 1 is congruent to angle 2. And let's go ahead and mark those. So angle 1 is congruent to angle 2. And I can see right away that those are alternate interior angles. So I know in your book it says congruent alternate interior angles imply parallel lines. You don't need to write all of that. Just write alternate interior angles. Okay. Angle 2 is congruent to angle 3. And one of the things you might have to do is turn your drawing around to be able to see the congruency. This is your transversal, line B, and it's transversing parallel lines C and D. And these two angles then become alternate exterior angles. And then we have the measure of angle 5 is plus the measure of angle 6 equals 180. Well, we know that those would be supplementary angles, so those would be consecutive supplementary angles. So when they ask you to state the postulate or theorem, simply write the shortest example you can give that still explains what they are. Now your homework for lesson 3.2 is numbers 1 through 15, 18 and 19, and number 23, and you've been given a word bank for 23. Right now, we're going to demo a few problems, and what I'd like you to do is update your notes with these theorems: 3.2.1, 3.2.2, 3.2.3, 3.2.4, and this is supposed to say 3.2.5. Be sure when you update your notes that you have pictures, just like the pictures that I've given you in this video. So the first problem we're going to look at is from page 117, and this is number 4. What they're asking for is for you to look at this picture and state which conclusion or conclusions can be made from each statement. And they have 4 different items you can pick from. They say that AB would be parallel to CD, or that AD would be parallel to BC, both A and B, or neither A nor B. And depending on which angles you're talking about would be which parallel lines were congruent. So for 4A, they say angle 1 is congruent to angle 5. So here's angle 1. It's congruent to angle 5, and it's on the transversal A and C, which is cutting across parallel line AD and BC. So that was the second option, which they're labeling B. And so that would be the answer. Let's look at number 5, just to take a look at that. Number 5 says angle 2 and angle 6. Those are alternate interior angles. And angle 2 and angle 6 are the transversal that cuts across parallel line AB and CD. So the answer to number 5 would be A. Number 15. In number 15, we have a shape that has 2 parallel lines with 2 transversals. We have parallel lines A and B, and we also have parallel lines C and D. Now I'm saying parallel lines, but we actually haven't proved parallel lines yet, so we can't state that yet. That's just how they appear. In number 15, it asks us to prove which lines are parallel from each given statement. Name the postulate or theorem that justifies your answer. Write none if there's not enough information. So the first angles that we have on this drawing says the measure of angle 5, which was this angle, and the measure of angle 15, which was this angle. And you know what these 2 angles are. We now have to state the converse of the theorem, not just the theorem. So for 15, this shows you that line C and line D would be parallel. So we would write that. And that is because of alternate exterior. It's the converse of the alternate exterior angle theorem. So look once again, you can see that the angles have the same measure. Even though you don't know what that measure is, you can see that it's the same. And instead of saying alternate exterior angles, we're actually going to say the converse, because we don't know yet if the lines are parallel until we state that they're parallel. Okay, our next set of angles is for number 16. And number 16 says the measure of angle 4 equals 3x plus 50 and the measure of angle 8 equals 130 minus 3x. Now number 16 is a little different. First of all, let's take a look at what the angles were that we're talking about. So the measure of angle 4 would have been this angle right here, and the measure of angle 8 is this corresponding angle right here. We know that they're corresponding angles, but let's look at their degree measure. This is 3x plus 50. This is 130 minus 3x. We have no value for x. We have no way to solve, so there's no way that we can answer whether these angles are congruent. So we have to state none. All right, number 17. Number 17 has a picture of a barn door. On that picture, there shows a rectangle with a transversal, actually two transversals, if you consider AF and BG to be parallel lines. And it says, this fence is designed so that AB is perpendicular to BG. CE is perpendicular to BG, and angle GFC is congruent to angle ECA. Okay, so let's mark those angles. Angle GFC and angle ECA. ECA. So these two angles are congruent to each other, and the rest of these are all perpendicular to each other. So what would be the measure of angle ABE? This angle right here. So angle ABE. Looking at the drawing, we can see that we have two angles right here that are congruent to each other. That will mean that CE is parallel to FG. So CE would be parallel to FG. And here's a transversal, and what do we have here? We have angle C which is created by the perpendicular of CE and BG. That means that this angle right here is 90 degrees. That means that this angle would also be 90 degrees. And if BG is perpendicular to AB, this angle would also be 90 degrees. Problem 24. We're asked to determine if lines A and B from the drawing are parallel. They give us the measure of angle 1 right here and the measure of angle 3, which I have denoted right here. And one of the things that you can see is you have a transversal. This line here is the transversal crossing two lines A and B. We want to prove if these are parallel. So we will make the assumption right now that angle 1 and angle 3 are corresponding angles and are congruent. Let's do some math and see if this works. If they're congruent, we can set them equal to each other. Perform our algebra miracles and solve this problem. So I'm going to subtract 3x from both sides and add 35 from both sides. That will give us 2x equals 60. So x would equal 30. And let's solve. So the measure of angle 1 would equal 3 times 30 plus 25, which would be 115, and the measure of angle 3 would equal 5 times 30 minus 35, which would be 115. So they are equal together, so A is parallel to B. Our last problem is a proof. This is the proof of theorem 3.2.1, the converse of alternate exterior angle theorem. This is our drawing that goes with that proof, and we are given that angle 1 is congruent to angle 8. What we're trying to prove is that A and B are congruent. So let's draw our two-column proof. And number 1, we'll have our statements and our reasons. We know the first one will be the given. And number 1 will be angle 1 is congruent to angle 8. Our second step. Will be, and actually there are a couple of different proofs you can do for this theorem, but I'm going to do the shortest one. We're going to say that angle 3 is congruent to angle 8. I look for the easiest thing that I can prove, and vertical angles are always easy to prove. So angle 3 is congruent to angle 8, and that is vertical angles. And because we've proved vertical angles, we can now say that angle 1 is congruent to angle 3. So we proved 1 is congruent to 8, 3 is congruent to 8. So now I can say that angle 1 is congruent to 3, and that is the transitive property. And guess what? We've proved alternate exterior angles. We've also proved vertical angles. And now we've proved corresponding angles. So we can state that A is parallel to B, and that is by stating that the congruency of corresponding angles, and here's some new symbology here, proves, or therefore, parallel lines. I would read this like congruent corresponding angles leads to parallel lines. That's a quick, easy proof. Hope this has helped. Give me a call if you need any assistance on your homework.